Hello students, I am Dr. Nimi Singh. Today I bring you the next learning module in PSC Forensic Science on a very important unit of the paper Criminalistics, that is Forensic Significance of Fiber Part 1. In this lecture, you will be studying about fibers, its classification, class and individual characteristics of fiber. In addition to it, you will also be studying about collection, handling and preservation of fiber. Lastly, we will wind up this lecture by studying how fiber is used as evidence in crime scene investigation and conclusion. So, our modules will be, the first one is going to be the introduction to fiber, the second one classification of fiber, then class and individual characteristics of fiber, the collection, handling and preservation of fiber, and then fiber as an evidence, and in the end we will conclude. The fibers from the perpetrator's clothes may be present on the victim's body or her clothing that may help in identifying a particular clothing type and finally help to trace the criminal. In this module, we will discuss about several kinds of fibers commonly encountered by a forensic scientist. Fibers are thread-like structures from fabric and other materials which are easily identifiable under a microscope. The fiber examination can determine whether the fibers are natural or man-made. Its source can be determined by comparing it with fiber from a known source. Natural fibers are mainly from a plant or animal source like cotton, silk, etc., while man-made fibers are made from synthetic materials like nylon, rayon, etc. The natural fibers can be easily detected by microscopy. However, most of the fibers used in the garments are synthetic, so accordingly, various methods are used to analyze them. Let us come to the classification of fibers. The most basic and important classification of fibers divides them into two types based on their origin. Let us come to the classification of fibers. Now, on the screen, a detailed chart is shown where all the fiber types are presented below. Fibers are mainly categorized into two: the natural fibers and the man-made fibers. The natural fibers are mainly from plant, animal and mineral resources. Now, accordingly, the natural fibers are divided into plant fibers, animal fibers and mineral fibers. The plant fibers are, as an example, we can consider cotton and flax. From animal fibers, we can consider wool, mohair and silk. Mineral, asbestos. Coming to the man-made fibers. Man-made fibers can be regenerated or synthetic. Regenerated fibers, examples we can have rayon, protein, rubber, cellulose, glass, while synthetic fibers, polyamides, acrylic, polyester, polyphenol, vinyl, etc. Now, we are going to discuss these categories one by one. Let us now discuss each of the above categories one by one. First, let us come to natural fibers. Natural fibers are made from raw materials obtained from plant and animal sources. Examples of natural fibers comprise of bamboo, hemp, cotton, silk, wool, etc. and are spun from short fibers into sliver, made into roving and then spun to form a continuous long fiber that may be woven, braided or knitted into a fabric. The fabric thus formed has a fluffy look. Unless finished, serged or otherwise treated, that results from the short staple fibers from which they are produced. Silk is a natural spun long polymer that is very much similar to man-made fibers. The resulting fabrics are shiny, smooth and are soft to touch. The fibers can be easily identified and compared by microscopic inspection itself. Now coming to the fibers obtained from plant source. The examples are cotton, jute, linen, etc. Fibers of cotton are mostly used in textile preparations. Cotton types, length of the fiber, the degree of twist are few characteristics which add variation in these fibers. The manufacturing process and color application also affects the importance of cotton fiber identification. Then we have fibers from animal source. Animal fibers, which are mostly used in textile materials, are wool, and the most common wool fibers come from sheep. The finer wool fibers are used in making clothing, while coarser wool fibers are used to make carpets. Thus, the diameter of the wool fibers holds importance in the analysis of the fiber from the crime scene. Another example for animal fibers is silk. Now, let us come to the man-made fibers. The synthetic fibers are formed due to the extensive research done by scientists so as to improve the quality of the animal and plant fibers. Usually, the synthetic fibers are formed by forcing through the spinnerets into the air by the process of extrusion, thereby resulting in the formation of threads. Earlier, artificially manufactured fibers were obtained from the plant cellulose and hence were also known as cellulosic fibers, whereas synthetic fibers are now obtained from small molecules or synthesized polymers. The compounds that are used in the making of the synthetic fibers are obtained from the raw materials such as the petrochemicals or the petroleum based chemicals. These materials are polymerized to form long linear chains having chemical bonds within two adjacent carbon bonds. Different chemical compounds will be used to produce different types of fibers. Man-made fibers are produced by combining polymers or small molecules. An example of a raw material is petroleum-based chemicals. The frequently employed synthetic fibers comprises of nylon 1931, Moda acrylic 1949, olefin 1949, acrylic 1950, polyester 1953, carbon fiber 1958. There are also different types of fibers like glass fiber, viscose, cupro, ammonium, rayon, aramides, etc. Class characteristics are common characteristics which are found in all the members of a group, such as color, size and general composition. Hence, in case of fiber, its color, size and general composition forms the class characteristics. Individual characteristics are features or signatures that define and identify an item as unique and exclusive of all other items. Individual evidence may be defined as a unique item that is identifies as itself to the exclusion of all other items. In terms of fiber, its chemical composition, cross-sectional diameter and weaving pattern, fluorescence, characteristics and optical properties comprises of the individual characteristics. A carpet fiber on a person's shoe can indicate the individual's presence at a crime scene, but since the fibers are very mobile and lightweight, they become airborne, get brushed off easily or fall from clothing. Although fibers can cling to each other or to hair, they can still be easily brushed off. They can be collected from carpets, victim's body, victim's clothing or suspected weapon. There are certain precautions one should follow while collecting the evidence. Photographs of all the evidence should be taken prior to collecting them. Collect large items such as clothing in separate paper bags. Do not keep suspect and victim items in direct contact with each other, which can actually lead to cross contamination. It should be made sure that the carpet and other materials that might have been transferred to a suspect or a victim are all collected very carefully. Bedding should be carefully handled to avoid the loss of evidence in the form of fibers. In case the evidence is wet, it should be air dried and collected in paper bag. The usual collection technique of fiber evidences comprises of collection by forceps of tweezers, tape lifting and vacuuming. Collection of forceps. Collection by forceps or tweezers. On most of the surfaces, if not all, the fibers can be seen with naked eyes. The fiber sample can be collected from the surface with the help of forceps or tweezers and trace paper. It is then placed on a clean piece of paper and is folded and packaged in a proper envelope or some other packaging bag very carefully lest the evidence may get contaminated. Then you have tape lifting. For the collection of fiber evidences, methanol and water soluble tapes are available. The tape is applied to the location of the suspected sample, removed and then packaged. The fibers stick to the adhesive side of the tape, thereby helping in their easy collection. Then comes the vacuuming method. The areas where the suspected samples are located are vacuumed in this technique, which gets caught in a filtered trap attached to the vacuum. These samples are then packaged in a clean traced paper to be submitted to the laboratory. Vacuuming is the least desirable of all of these collection methods because there is always a risk of cross contamination if the equipment is not cleaned properly in between every use. Fibers are a form of trace evidence which are small and easily transferable. These are very useful in crime scene investigation as they can be easily identified under a microscope easily. Fibers are defined under microtraces. Microtraces as evidence have great importance and mainly for the following reasons. Microtraces are almost always exchanged in accordance with the principle of exchange. Hence, they are present in all crimes. They often remain unnoticed and hence undistributed, unmutilated or undestroyed and thus can provide useful evidence. In fact, the culprit is often unaware of their existence, location and their value. He therefore does not take the usual precautions to prevent their occurrence or deposition. Microtrace evidence, like other evidence, can help determine the corpus delicti. Microtraces permit identification of the culprit, the victim and of the various materials involved in the crime. For example, the root of a hair after comparison of its DNA profile with that of the suspect can establish the identity of the culprit. Microtraces can link or delink a suspect with the crime. It provides investigative leads. Microtraces fix the identity of the scene. They help in the reconstruction of scene of occurrence, that is, the sequence of various events at the scene of the crime and the modus of operandi. Transference and cross transference of fibers frequently take place among all the persons, places and paraphernalia which are involved in the criminal cases through wearing apparel, carpets, upholstery, bedding, textile mills, draperies, furriers, etc. Fibers surround us all around, so much so that it is actually difficult to imagine a person who would not transfer and or pick up fibers even in his day-to-day functioning. This transference and cross transference also takes place in criminal situations. The fibrous evidence therefore should be available most of the time, most of the crime situations, on most of the persons and materials involved. A mutual exchange, one established, clinches the case against the accused, as it provides the necessary corroboration, especially in cases of offences against the person, to main evidence of the victim and the eyewitnesses. Fibers are valuable evidence because of the large variety and frequent exchange. It has been calculated that if 6 different common fibers, different in color, size, material, treatment to extent of use, have been exchanged, they provide the linkage. Fibrous evidence is often inconspicuous. It remains unnoticed. The culprit therefore does not destroy it. For the same reason, the evidence also remains untampered. But all the fibrous evidence does not remain attached to the surface. In fact, most of the fibers are shed off soon. Some, however, resist shedding and even withstand dry cleaning or washing. They provide excellent evidence even after a long period. Unfortunately, the fiber evidence has been considered to be a weak evidence, as it was supposed to offer no individualizing features. But it is no longer true. The fibers can be highly individualistic due to the following characteristics: the chemical composition, the manufacturing process, the dimensions, dyes, optical properties, impurities from the manufacturer, wearer, partial melting, paint smear or other stain changes in the material due to aging. Coming to the source determination. Fibers can be exchanged or transferred from individual to individual, individual to object, and between objects also. If fibers get associated with a particular source, for example, a fabric, then it becomes easy to link the victim, suspect and the scene of crime, thereby giving it evidentiary value. The probative weight of this value is dependent upon many factors. The factors comprises of the type or types of fiber found, color or colors of fibers, number of fibers found, location or locations of fiber, type or types of fabric, multiple fiber association, nature of contact, fiber transfer and persistence, fiber source. Let us discuss each of these factors one by one. Coming to the type of fibers found. Type or types of fiber found. The probative value of the fiber evidence found at the scene of crime is affected by its rareness or commonness. In textile production, cotton fibers are the most commonly used fibers of plant origin. The type of cotton, the fiber's length and the degree of twist contribute to the diversity found in common in cotton fibers. Manufacturing processes, for instance, mercerization and color application also affects the importance of fiber evidence. The presence of other plant fibers at the scene of crime, which are otherwise less common, increases their importance. Wool is the most common animal fiber used in textile production and it is originated from sheep. The presence and identification of less usual animal fibers, hairs, are both present at the scene of crime or on clothing of victim or suspect serves as significant evidence. Not all manufactured fibers are synthetic in nature, such as rayon, and that some manufactured fibers are more commonly used as compared to others. Few examples of commonly encountered manufactured fibers comprises of nylon, polyester, acetates, rayon and acrylics. The amount of production, the end use, the cross-sectional shape, microscopic characteristics and other traits of the fiber help to influence the degree of rarity of a particular fiber type. Coming to the colors of fiber, one of the greatest variations seen in textile is color. Thus, color greatly influences the significance of a fiber comparison. There are actually 29 different chemical categories of synthetic dyes and pigments having more than a dozen of various application methods. Even 8 to 10 processes are needed in case of simple dyes, so as to convert the raw materials into a finished product. Before the fibers are being spun into yarns, they can be colored individually, or the yarns can be dyed after being spun, or dyeing of the fabric can be carried out before or after its construction. The surface of a fabric is colored by the help of printing process. The fiber length absorbs the dye, and this implies the types of dye and the dyeing method used. Fading and discoloration may also add increased significance to a fiber association. Coming to the number of fibers. The number of fibers identified on the clothing of a victim associated to the clothing of a suspect is important in determining the actual contact. The greater the number of fibers, more is the likeness that direct contact occurred between these individuals. The converse is not necessarily true. However, and even one fiber association can have probative and scientific value. Additionally, finding no fibers does not de facto meaning that no contact occurred. Each case is different, and the examiner must weigh all the relevant factors before determining the significance of the evidence. Now comes the location of fibers. The location of fibers on different areas of the body or on the specific item at the scene can influence the significance of the fiber association. Types of fabric. The construction of fabric may affect the type and the number of fibers which may get transferred. Fewer fibers will be shed by those fabrics which are tightly knitted or woven as compared to those fabrics where the fibers are loosely knit. Fabrics which are formed by spun yarn shed more fibers as compared to those which have filament yarns. Transference of certain types of fibers is more as compared to others. The degree of fiber transfer is also affected by the condition and wear of the fabric. Newer fabrics may have an abundance of loosely adhering fibers on the surface of the fabric, whereas worn fabrics may have damaged areas that easily shed fibers. So, during physical contact, the likelihood of fiber transfer is greatly increased because of the damage caused to the fabric. Coming to the multiple fiber associations. If many different fiber types are associated among the suspect, victim and scene, then the likelihood that contact occurred between these items is greatly increased. Each associated fiber transfer is considered to be an independent event, and multiple associations undermine an argument that the fibers were all deposited by coincidence. Coming to the nature of contact. The number of fibers transferred will determine the type of physical contact between a victim and the suspect. Violent physical contact of an extended duration may result in many fiber transfers. Fiber transfer and persistence. Transference of textile fibers on the surface of a fabric can result from primary or direct transfer or by secondary or indirect transfer. The likelihood of transfer depends on the types of fabric involved in the contact and the nature and duration of the contact. Studies have shown that transferred fibers are lost at a geometric rate depending on the types of fabrics involved and on the movement of the clothing after contact. For instance, fibers may be retained on the clothing of homicide victim as the victim is not moving. Therefore, under these circumstances, it is difficult to predict precisely how many fibers might remain on the clothing of a living individual after a given period, but it is important for investigators to retrieve clothing immediately. Coming to the fiber source. If questioned fibers are associated with known fibers, the questioned fibers either originated from the known textile or from another fabric source, which not only is composed of fibers of the exact type and color, but also from a fabric that had to be available to contribute those fibers through direct or indirect contact. The chance is therefore remote to encounter fibers from the environment of a victim that are identical to fibers from the suspect's environment or environments in the absence of contact. Fiber evidence is useful in crime scene investigation because their origin can be identified. However, fibers are very mobile and can become airborne, get brushed off or fall off from clothing. Fiber evidence can tell a lot about crime if processed correctly. To determine whether fibers in threads belongs to the same source or not, the same obtained from the body of suspect's clothing can also be compared. Fibers prove to be very helpful in cases of sexual offences, assaults, etc. In such a case, it is possible to demonstrate or indicate that a contact took place between two individuals or between a person or an object, for example, a car seat. Such examinations are only of value when it is known no contact occurred between the two individuals or an individual and some other object prior to or subsequent to the offence. Let us now conclude our lecture. Fiber as trace evidence holds much of probative value. It gets easily transferred on various surfaces which come in contact with it. They are generally found in sexual assault cases and hit and run accidents. Hence, because it can help in linking the crime scene, victim and the suspect, it should be collected with great care so that no cross contamination occurs. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I will see you in the next lecture. Have a great day.